So this is kind of a theoretical part now, that if you have T, a linear transformation from U to V, with matrix representation A, which is then the matrix representation when we have bases V and U, then if T is invertible, then what we get is that the T inverse is actually a linear mapping from V to U. And what we have is that the inverse matrix has matrix representation. Then we go from the BV basis into the BU basis, which is just the inverse of the matrix. So again, the fantastic thing is that instead of inverting abstract transformation over abstract spaces, this is just regular matrix inverse. So an example for inverses, T is from P3 to P3. Polynomial is the degree 3 or less. It's defined by T of ax squared plus bx plus c equals to 4a plus b x squared plus minus 3 plus 3b plus cx minus a. Then we would like to find the inverse of T. And more precisely, we would like to see how it looks in general for polynomial of the form ax squared plus bx plus c. So in this case, actually P3 is the degree 2 or less polynomial. So this is a little bit of different definition than we used before, or we can just say that there is no degree 3. But of course then it's not T is not well defined. So following our previous notation, let me change this to P2 and note that in WebWork this is kind of an incorrect notation. The reason for that is because this is the degree 2 or less polynomial, but actually it has dimension 3. So P3 might make sense if we talk about the dimension. P2 makes sense if we want to talk about the highest degree of X. So in some sense this is too much information actually. What we really need is only the value of the transformation over the standard basis vectors 1, x, and x squared. So that would mean 0a and 0b for 1. So a is equals b equals 0 and c equals 1. What we get here is 0x squared plus x minus 0. Then for tx, this is a equals 0, b equals 1, c equals 0. So this will be x squared plus 3x. And for x squared, we have this is a equals 1, b equals c equals 0. So we get 4x squared minus 3x minus 1. And if we really create a matrix for this, then we have 0, 1, 0, 0, 3, 1, minus 1, 3, minus 3, and 4. Then to calculate the inverse of this matrix, let me use MATLAB for this. Minus 15, 1, minus 3, 4, 0, 1, minus 1, 0, 0. And that means that the T inverse ax squared plus bx plus c will be A inverse applied, let me write down the whole thing correctly. So the standard base is 1x x squared, and then this has to be multiplied by A inverse and the c be A coordinate matrix of this polynomial. So this will be 1x x squared, and the A inverse minus 15, 1, minus 3, 4, 0, 1, minus 1, 0, 0, and multiplying CBA, we get that this is 1x x squared, and then the matrix multiplying the coordinate matrix, the inverse transformations matrix representation, we get minus 15c plus b minus 3a, 4c plus a, and minus c. And then multiplying the row vector with the column vector, we get minus 15c plus b minus 3a, plus 4c plus a times x and minus cx squared.